Hey folks, welcome back to another video. Today we're looking at question 695, maximum area of island. The way we'll be approaching this problem is by using recursive DFS. So let's jump right in. The first thing that we need to do is to get the number of rows and columns. So let's do just that. Right, next up we will have two for loops that will iterate over each row and every column. So since we have the limits already for the rows and columns, let's use that to write the two for loops. And so j would be less than n, increment j. And so since it's a recursive DFS, let's write a helper method for that. But right before that, we would also want to keep a track of the maximum area that we've seen so far. So let's initialize an integer called max and store that to be 0. And if the value that we're looking at right now is equal to 1, that means it is an island. We would call recursive DFS on that particular cell. So max would be max.max of either what we've seen currently, or let's call it DFS of what all would we need in the helper method. We would need the grid itself, we would need the current coordinates that we're looking at, and we can also send in the limits for to do the checks when we're passing in x and y coordinate, which makes it so much easier instead of having to calculate it every single time. And in the end, we will just return the max. Awesome. So let's actually write the DFS method right now. So it'll be int DFS. So first off is the grid. Next are the I and j indices, and then later the limits. So m and n. Awesome. So let's look at the base case first. So if we have I less than 0, or j less than 0, or I greater than or equal to m, or j greater than or equal to n. So you see that we're looking at limits using m and n right here. We could have possibly done that just by looking at the length of the grid by calculating it right here, but it just easier this way. You don't really have to like call the length method every single time this condition is hit, so it's just easier to do it this way, just by passing in the limit. So much easier. And the last thing that you're checking is if the value of the grid cell that we're looking at right now is equal to 0, you would just return 0. Otherwise, if it is not 0, we know that it is 1, and we'll set the grid value to be 0 because we want some way to represent the fact that we have already visited that, and the value that we'd be returning is 1. That means since the current cell that you're looking at actually is 1, that means the area is 1 plus the surrounding islands. So what would that mean? So DFS, you would call that on all the 4 coordinates: up, down, left, and right. So this would be right, and let's do that for all of the other neighboring coordinates as well. So let's clean this up a little bit. Right here, this goes away. Here, and this is here. Awesome. So let's quickly compile this and see if it's okay. The first test case looks okay. Everything else looks okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution would be of n into m because we are iterating through every single cell within the given matrix. And the space complexity, oh my bad, it would actually be of 1 since we're not really using any additional space to store additional data. So the space would be of 1, the time complexity would be of n into m. Awesome. So if you have any questions for this problem, please let me know in the comments below. Don't forget to subscribe. I would really appreciate that. And if there are any other problems on LeetCode that you want me to solve, also let me know in the comments below. I'd be more than happy to solve that for you. I'll see you all in the next video. Have a good day. Peace.